Welcome back to part 2 of lesson 1.2.3, Introduction to Electricity. Last lesson, we learned the relationship between a battery, which is pressure. The bigger the voltage, the more the pressure. So the more pressure you have, the more electricity you have flowing through. We learned about resistance, and it's like a kink in the pipe. The bigger the kink in the pipe, the less electricity flows. The less the kink of the pipe, the more electricity flows. And then we talked about current. That's how many electrons per second are flowing through a conductive pathway. Today what we're going to talk about is how to measure these things. There are very specific ways to measure voltage and current. So I'm going to talk to you on how they're similar, how they're different, and if you screw this up, you can break the meter. And this is like every physics, every electronics, every engineering teacher across the entire continent and world, we rue this day because there's a fuse inside of here. Like a fuse, I think there's a fuse over here that kind of explains how fuses work. If too much electricity flows, let's see. Yeah, so let's see if we can show you how a fuse works. I'm going to hook this fuse up. Bing. So I've got electricity. Fuses work like this. If too much electricity flows through here, I'm going to up the pressure. If too much electricity flows, the fuse is going to burn and break. So I'll just keep pushing until I break it. Yep, there it goes. Fuse, gone. And it breaks, and this one you saw before, it's got a rating of 4 amps. The fuses in your house, they're typically 15 or 20 amps, depending upon how thick the wires are in your house. The thicker the wire, the more electricity they can handle. So your house, it all depends on the wire. The thicker the wire, the more electricity it can handle before your circuit breaker trips. And the only difference between a circuit breaker and a fuse, fuses, you have to buy them. You have to like throw it away, go to the store, buy another fuse. But a circuit breaker, you just flip the switch. And how does that work? Really wonderful invention. It uses magnetism. I can tell you more about that. Just ask me and I'd love to talk your ear off about it. But suffice to say that inside of a voltmeter, if you do this wrong, there is a fuse internally that will break that we have to then go to the store, buy a new fuse, put inside of this thing. So pay attention. And if you're not sure, always ask. And you're probably going to blow out a fuse, and that's okay. Shame on electricity. But if you continue to blow out fuses, shame on you. I need you to learn the difference, how to hook these up and make your measurements correctly. So let's get started. We're going to learn today how to measure voltage and current inside of a circuit. So I'll make some nice easy numbers here. Let's go 20. We'll go 20 volts, and then this resistance will make it 10. So 20 and 10, pretty straightforward. To measure voltage, let me get rid of this guy. To measure the voltage, and this is a voltmeter, and believe it or not, a voltmeter and an ammeter are exactly the same. They look identical. You just turn a little knob. Let me go grab one. Here I have what's called a multimeter because it measures multiple things. There's a little knob that you turn here to measure voltage and current. So one device will do both of these things over here. It will measure both voltage and the current. All right, so let me talk to you about how you measure and why you measure it this way. Remember how I talked to you before how voltage is like pressure? If you increase the pressure, you increase the current. And increasing the pressure doesn't do anything to the resistance, by the way. I'm just pushing through the same kink in the hose. So if I'm measuring pressure, I need to measure on both sides because there's a high pressure here, like I'm pushing the electrons this way, and there's a low pressure over here. So on voltmeters, there are two what we call probes. The red one goes on the positive side. I think that this is positive side. We'll see. This is negative. Nope, I did it backwards. And I know I did it backwards because I have a negative. It's hard for me to tell which way is the positive one here. So put the black one here, and I'll put the red one here, and you'll see that I get 20 volts. And that's the voltage of our battery, 20 volts. Now, what would happen if I put my probes here and here? I get 0. There's no pressure difference right here. It's the same pressure here as over there. And if I put my other probe here, it's still 0. It's only when I go across, here's my kink in my hose. Remember, if I kink the hose, if you kink the hose here, there's a high pressure here, and there's a low pressure there. And so then I get 20 volts. Coming up, whoops, if I put my probes here and I put my probes here, there's no pressure difference, so that gives me a 0. Putting my probes here, and then I go around the battery, there's a pressure difference of 20 volts. So important fact, when you measure voltage, you don't have to unhook anything. You don't have to unhook it. You just touch the circuit. I'm going to write that down. When you're measuring voltage, and only voltage, you don't unhook anything. You don't have to, you just leave the circuit go and you start touching. Bring this thing in here, touch your probes to some conductive surfaces, and away you go. That is completely different than how we measure current. Now, when we measure current, because current is how much electricity is flowing through here. So the only way to measure how much water is flowing through the pipe, you gotta cut open the pipe and you gotta put a little propeller thing in there to measure how much water is going through it. And the propeller, that propeller needs to spin really, really freely. You can't kink the pipe at all. So to measure the current, what you have to do is you have to open up the circuit. You have to physically unhook something. And then you're going to put your meter in there. So you're going to hook this up like this and like that, and then you're going to measure the current. So I have to unhook it. So maybe I want to measure the current over here. So what I do, I unhook this, break the circuit, bring my meter in, hook my meter up, and it will tell me how much current is there. Maybe I want to measure the current right here. So I unhook this, bring my meter over, hook this up, and you'll notice everywhere I put it, it says 2 amps. Talk about that in a little bit, but what's important is when you're measuring current, you have to open the circuit. You have to unhook the circuit. When you're measuring current, break the circuit. Unhook. Now, when we do this in real life, my voltmeter looks like this and my ammeter looks like that, but in reality, it's the same thing. It's the same object. So it actually looks like this. So if I was going to measure the current using this thing right here, I would break my circuit. I would hook one of these probes up to here, and I would hook one of these probes up to here, and that would have the electricity. I wish I could turn a knob here and have the electricity start flowing. This is where this one little animation interactive breaks down, because it doesn't show this very well. This is how you would hook up a circuit to measure the current. Now here's why. Gosh, let's see if I can explain this adequately. Why do you burn out fuses? Like, if you hook this up wrong, you're going to burn a fuse. So if I can do it for you right now. This would be cool. what if I measure current, but I hook it up by just touching? Watch this. I'm going to hook this up by just touching. Remember how I did it before? I brought my voltmeter in and I just touched. I touched this piece here and I'll touch this piece here. Oh, see how I get 20 volts? No problem. That's how I'm supposed to do it. I'm measuring voltage by just touching. Watch what happens if I measure current and I just touch it. A short circuit, right? Remember how I told you before that in order to measure how much water is flowing through this circuit, we need to cut it open and we need to put a propeller in here? This thing, in order for it to measure current effectively, it needs to be able to let electricity flow through with no resistance. I don't want to be adding another kink to the pipe here. I want to put this in here and I want the electricity to flow through perfectly and easily. So, if you hook it up incorrectly, remember that this thing doesn't have any resistance. If you take this thing and then you hook it up, so this has no resistance, it's just like hooking a wire up. So the electricity will flow straight through this meter and you get infinite amount of current and you get a short circuit. And this is where the fuse comes into play. Inside of these meters, there is a fuse that if you hook this up incorrectly, it might beep at. If you hook up your meter and it starts beeping at you, it's saying stop, 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 stop. Immediately unhook. Sometimes if you just get way too much current, it won't even beep at you and it'll just stop. It will look like it's working, but it just won't read anything. You're like, I'm not getting any readings. That's because the moment that you hook this up, well, here we go, watch. Big. My fuse protected this thing. Because if too much electricity flows, the circuitry inside of here can heat up and melt, and then you really ruin. I mean, this is a $120 meter, and you could replace a 25-cent part, or you can replace $120. So this fuse is inside of here to protect it. So if you hook these up wrong, the fuse here will protect it from letting too much current flow. There it goes. So this is what's really important, kids, and this is what worries me when I let you use these in the lab setting, is that you pull out your meter and you're like, cool, let's measure current, and then you just touch, and that's all it takes, and it's like, now you have to tear this thing apart, and you have to do it. And if you didn't learn your lesson, you'll keep doing it, and I'll run out of fuses, and then people won't be able to take their measurements, and it's frustrating. So if you're at all don't know, just call me over. Especially current. You can't screw up voltage. Like, it'll be fine. Like, you take a voltmeter, and then you break the circuit, and you're like, oh, I'm going to touch this, and I'm going to touch this. No big deal. These things have tons of voltage, and it has to be that way, because if you go to touch this and you want to get an accurate reading of the voltage, you don't want electricity going through the meter. Like, you want to force all the electricity to go through the circuit here and not around like you saw when I brought it my ammeter. So voltage, you can't screw it up. It's idiot proof. Unless you go touching something super high voltage, and that's bad. But current, this is the one that if you hook it up wrong, you'll blow the fuse every time. On your meter, I wish I could make myself full screen. On these meters here, if you look really closely, you'll see which one to put it on. If you look here, it'll say voltage direct VDC. That's what we're going to be using all the time. Direct current. Alternating current is for the wall. When you have sinusoidal voltage, don't worry about that. That's kind of a little bit more advanced than you. But don't worry. We're only going to be using over here voltage direct current. And then if you want to measure current, then you're going to move this over here to either most likely milliamps. Now, and you'll see over here I can actually measure in the amp range. Down at the bottom, it tells you how much it is fused at. So down at the bottom here, it will say how many amps. And this one says 10 amps. So this thing, if you unplug the red one from here, and then you plug it in over on this side, this is telling you 10 amps. So that's the maximum amount of current that's flowing that you can take, and then the fuse will blow. Putting it over on the other side, it says 200 milliamps. So when I plug it in over here, the maximum amount of current that it can withstand is only 200 milliamps, or 0.2 amps. I think this is where I'm going to end it today. I'm going to do a specific one on your multimeter here where you can see it in full screen.